Let's consider the pH calculations that we have worked out so far. So the most straightforward one, I'm going to call these 1A and 1B. They are when we are just calculating the pH of a strong acid or a strong acid plus a strong base, where we've got acid in excess. And in both of these situations, we would just use the minus log to the base 10 of the hydrogen ion concentration. So those are our easy calculations. And then we moved on to considering strong bases. So type 2 is just a strong base calculation. And we could have a strong base with a strong acid. But with the base in excess. And in this situation, we would use Kw. And then last week we started looking at weak acids. And we used Ka. And we also used the approximation of H plus squared over the undissociated acid. Now, the next one we're going to consider is, as you probably could predict from this list, a weak acid plus a strong base. And for this one, you do use Ka, but not the H plus squared approximation. There's another calculation that we're going to look at in this video, which is a weak acid plus salt to prepare a buffer. And again, we use Ka with this and not the H plus squared approximation. Before we move on to looking at that type of calculation, just have a quick aside about something called a buffer solution. So a buffer solution is a solution that resists a change in pH when small amounts of acid or alkali are added to it. So in biology, you might have come across buffers if you're doing an enzyme experiment and you're trying to keep it at the same pH, and maybe you've come across the word in chemistry as well. We actually make buffer solutions in the lab in two ways. But a buffer solution contains two substances. It contains a weak acid and it contains the salt of that weak acid. So say we used ethanoic acid, and then we would have in there as well some of the salt, say the sodium salt of the weak acid as well. There are two ways to prepare them. So these salts are actually just available as solids. So the easiest way to do it is to take the weak acid and add a quantity of salt when we see that as a calculation, that's a 4-mark calculation. And then the other way is to take the weak acid, add a strong base to form the salt in situ. And when that appears as a calculation, that's a 6-mark calculation. So let's have a look at an example of this calculation, which I've written here. So we have a buffer solution, and we've been given the 2 species involved in the buffer solution, ethanoic acid and sodium ethanoate. So this is quite straightforward because we've been given the concentrations of each. So you've got a concentration of ethanoic acid and a concentration of sodium ethanoate and the Ka for the acid that is involved. So let's write the Ka expression. So we've got Ka is equal to the concentration of the ions in our ethanoic acid over the concentration of the acid. Now, the one thing I need you to remember here is that you cannot use that H plus squared approximation because you have got salt added. Now, where are we going to get these numbers from? So we've got Ka already. The acid, you've already got a concentration for that as well. And the sodium ethanoate, you can assume that the sodium ethanoate is providing all of the salt ions here. So hopefully you can see from that we've got Ka, we've got the anion, the negative ion, and we've got the concentration of the acid. So all we need to do now is to rearrange to get H plus, and we'll be able to do the pH calculation pretty quickly. So let's just rearrange this. So concentration of H plus is Ka divided by the concentration of the anion times by the concentration of the acid. So we've got 1.76 times 10 to the minus 5 over 0.103 times by 0.186. And the answer to that is 3.18 times 10 to the minus 5. Let's pH it, minus log, which gives us a pH of 4.49. And we have to think mentally, is this a sensible number? It's an acidic buffer, it's an acidic pH that's come out, and it's a weak acid, therefore 4.49 seems quite sensible. Modifications on this calculation. So you could have grams of the salt, so have to use moles equals mass over MR. They could give you volumes and concentrations instead of just straight concentration, so some combination of volumes, concentration, moles. So that's how they can make it more involved. The version I've just given you is 3 marks because they've given you everything as a concentration. It can be 4 or 5 marks depending on what other modifications they make for it. So I'll put you a few examples of these for you to practice.